Welcome to this explainer. As neurosurgical postgrads, you're using the Jendrassik Maneuvre, right? Pretty much every single day in the clinic. But let's take a step back and really think about it. What is literally happening at the spinal cord level the exact second your patient locks their fingers and pulls? Today, we're going to dig into the exact neurophysiological mechanisms behind it. Let's look at the evidence.
So for a long time, there have basically been two competing theories on this. Theory number one, fusomotor or gamma system activation. And we know the gamma system gets fired up by both physical and mental activity. Theory number two, on the other hand, points to a reduction in presynaptic inhibition, specifically of the alpha motor neurons by those IA afferent fibers. Now, the absolute key difference here is that this second mechanism is triggered purely by physical activity. Mental arousal doesn't affect it at all.
To untangle this, let's go back to a really elegant foundational study from 1978 by Bussell and colleagues. They actually used an ischemic block on a subject's leg. Why? To literally cut off the large diameter IA afferent nerve fibers coming from the soleus muscle. Basically, they completely eliminated any possible fusomotor effects. But here's the wild part. Even with that gamma loop totally out of the picture, the H reflex, it was still strongly facilitated during the maneuver. So, right off the bat, we had this incredibly robust evidence showing that the gamma system just couldn't be the main driver here.
Okay, so if the reinforcement isn't coming through the gamma loop, how do we actually prove, without a doubt, that it's an alpha motor neuron thing? Well, it all comes down to clever study design. You have to completely separate physical motor contraction from mental arousal. Because remember, the fusomotor system, it answers to both. But presynaptic inhibition, it only cares about actual physical contraction.
And that is exactly what Passmore and Bruno did in their 2012 trial. They set up three conditions for the patellar tendon reflex. At baseline rest, they measured about 256 microvolts. Then, they introduced a cognitive Stroop task, the gold standard for causing mental arousal. And almost nothing happened. The amplitude barely ticked up to 265.9 microvolts. But the moment the patient did the physical Jendrassik maneuver, bam, that amplitude practically doubled, spiking all the way up to 500.7 microvolts.
So what does this actually tell us? Well, if the fusomotor system was running the show, that mental Stroop task absolutely should have facilitated the reflex, but it didn't. And that lack of a response completely validates our second theory. The Jendrassik maneuver operates by reducing presynaptic inhibition of the alpha motor neurons. Now, for your clinical practice, timing is literally everything here. This reinforcement effect is incredibly fast. It only lasts anywhere from 1 to 6 seconds, and it hits its absolute maximum peak at just 300 milliseconds. Just to wrap up, here are those two foundational articles we just walked through, completely validating this framework. The big takeaway for your day-to-day practice? It is the anatomically remote muscle contraction, not just mental arousal, that is temporarily altering that spinal excitability. Which kind of leaves us with a fascinating question to chew on. If this is what's happening here, how might other, maybe unknown oligosynaptic pathways be secretly modulating these reflexes during our routine exams? Something to think about next time you reach for your reflex hammer.